In 1665, the English natural philosopher Robert Hooke published Micrographia, a book that changed how people understood the natural world. Among its most striking images was a telescopic drawing of the moon, not as decoration but as evidence. Hooke showed a surface that was rough, uneven, and marked by deep depressions, directly challenging the long-held belief that the heavens were smooth and perfect. Today, with modern lunar maps and photography, historians have asked a fascinating question. Does this drawing correspond to a real lunar feature we recognize now, possibly the large crater known as Hipparchus? In this video, I'll examine what Hooke actually observed, what he said about it, and why modern scholars believe his centuries-old sketch may depict a specific and identifiable place on the moon. When Micrographia appeared in 1665, astronomy was in the midst of a quiet revolution. Telescopes had existed for only a few decades, and their meaning was still being worked out. For centuries, the moon was widely assumed to be smooth and perfect, fundamentally different from the Earth. Even when rough features were noticed, they were often dismissed or poorly described. Early telescopes began to challenge this view. Unexpected shadows appeared, along with bright rims and dark patches that hinted at height, depth, and structure, but only if interpreted carefully. What set Robert Hooke apart was his insistence on disciplined observation, rather than speculate about what the moon ought to be. He focused on what could actually be seen, recorded, and compared, marking a shift from inherited ideas to evidence drawn directly from nature. When Robert Hooke turned his telescope toward the moon, his goal was not to create an attractive image, but to demonstrate physical reality. He wanted to show that the lunar surface was uneven, rugged, and shaped by real topography. Through the telescope, bright rims and dark interiors revealed mountains rising above deep cavities and broad depressions. These features were not imagined. They emerged from changing patterns of light and shadow as the moon moved through its phases. Hooke studied these shadows carefully. Their length and direction provided clues to height and depth, allowing him to infer the moon's three-dimensional structure. In Micrographia, drawings like this functioned as data, visual records meant to support the idea that careful observation, not speculation, was the foundation of scientific knowledge. Shown here are two images separated by more than 3 centuries. On the left is Robert Hooke's original lunar drawing from Micrographia. On the right is a modern telescopic photograph of the crater, now known as Hipparchus. At first glance, the two images are not identical, and they should not be. Hooke worked with an early telescope, limited resolution, and hand-drawn technique. His image records what he could observe, not exactly what we can see today. Yet the resemblance is striking. Both show a large, roughly circular depression with an uneven interior and a broken rim. The patterns of light and shadow suggest depth, scale, and surface complexity, consistent with a vast, ancient walled plain. This comparison does not prove that Hooke set out to draw Hipparchus, but it strongly suggests that his observation corresponds to the same real lunar feature, later mapped and studied by modern astronomy. In Micrographia, Robert Hooke notes that many features of the moon are visible even without a telescope. He writes that there are divers great spots to be perceived on the surface of the moon, with the naked eye, especially about the middle of her body. Viewed through a telescope, Hooke explains that these dark regions are not smooth at all, but great cavities or depressions of the surface. Their darkness, he argues, results from the way sunlight strikes them at an angle, producing shadow rather than reflection. This passage shows that Hooke understood these lunar features as real, three-dimensional structures, defined by light, shadow, and depth, not illusion or surface coloring. It's just as important to note what Robert Hooke does not say in Micrographia. He never names a specific crater, nor does he claim to have identified a particular location on the moon in the modern sense. Hooke provides no coordinates, no formal map, and no system of lunar nomenclature. His drawing is not presented as definitive or complete, but as a careful record of what could be observed with the instruments of his time. This restraint is deliberate. Hooke understood the limits of his observations and left room for future investigation, an approach that reflects the emerging scientific method of the 17th century. Modern lunar science tells us that Hipparchus is a large and very ancient impact crater located to the southeast of Sinus Medii. Measuring roughly 150 kilometers across, it is among the prominent walled plains visible near the center of the lunar disk. Over billions of years, later impacts have eroded its rim and roughened its interior, giving it an irregular, worn appearance rather than a sharp, well-defined shape. At low resolution, this combination of surface texture and shadowing caused the crater to appear noticeably darker than its surroundings. These characteristics closely match the kind of large, shadowed cavity described by early telescopic observers like Hooke, linking modern lunar geology with 17th century observation. In Micrographia, Robert Hooke never named the lunar feature he drew, nor did he claim a definitive identification. What he offered instead was careful observation, recorded honestly, with a clear awareness of the limits of his instruments. Today, using modern lunar imagery and mapping, most scholars favor identifying that feature with the crater now known as Hipparchus. This conclusion rests not on certainty, but on a strong visual and descriptive agreement. This episode reminds us that science advances cumulatively through observation, comparison, and reinterpretation, building new understanding upon the careful work of those who came before. Thank you for watching.